Chapter 4, The Distribution of Life on the Earth. Speciation and Diversity. Speciation occurs, especially in higher organisms, through isolation. When species are isolated, they tend to evolve into separate species from the ones they were isolated from. There are three main ways this could happen. Reduction of habitat may leave small isolated populations called peripheral isolates that then become new species. In addition, barriers may form to isolate populations. And finally, populations can migrate outside of a given area and become isolated as separate populations. This figure compares physical changes in the Earth to evolution of life on the planet. Note that the timeline on the left is not to scale, and that the top 2/3 of the figure only represent about 1/9 of the geological time since the Earth's formation. Near the bottom, in the atmosphere column, it shows an increase in production of molecular oxygen. This is called the Great Oxygen Event, and it started about 3.6 billion years ago, and only accumulated about 1% oxygen in the atmosphere over the next few million years. By the time we got 20% atmospheric oxygen, it was around 800 million years ago, shortly before multicellular eukaryotic life evolved on the planet. This is because, this is because organisms that use oxygen to burn carbon and get energy get a lot more energy out of it than those that don't. And you need that energy to sustain higher life forms and more complicated cells. Also note the relatively cool temperatures over the last 30 million years or so when mammalian life grew to dominate the planet. Over time, the level of diversity has tended to increase. The major explosions of life happened in the past and can be documented in the fossil record. One of the the largest of these is called the Cambrian explosion, and it's in the fossil record of about 570 million years ago. That said, there's also been several major extinctions over the recent history of the planet. For instance, the end of the Mesozoic era with the extinction of the dinosaurs. Periodic mass extinctions have strongly influenced the pattern of diversification, and the extinction of dinosaurs 65 million years ago most likely allowed mammalian life to dominate the planet today. We are currently at a very high level of species diversity due to stable, relatively cool climate, but there's concern the environment is changing rapidly. So what is biodiversity? Biodiversity's most common measure is biodiversity is the variety and variability among living organisms and the ecological complexes in which they occur. We can measure biodiversity a bunch of different ways, but usually we just count species or estimate species within a certain area. Species richness is the number of species in that area. On the left-hand side of this, you see two regional and local charts that show low levels of biodiversity or species richness compared to the blue diagram that shows a higher level. Notice this isn't about abundance, but the number of species in the area. So you could have low diversity, but a high abundance. Here's a high abundance of A, but low diversity. Here's lower abundance, but more diversity. Biodiversity can be measured using local, regional, or global scales. Biodiversity varies wildly around the planet and over time. It's been estimated to be about 1.8 to 2 million species have been described on the planet. These numbers are hard to verify because it would take a long time to count 2 million species, or even look up the numbers of species other people have counted. In addition, not all groups of organisms or parts of the world have been studied equally. The areas with the most species we find are in the tropics near the equator, and they are the least described. When estimating numbers of species, we use a bunch of different methods. Trying to count all the species is hard to do, and therefore we've developed methods over the years to try and give us an idea of how many species are in a given area. For example, in the book they talk about rainforest insect samples that help estimate biodiversity with limited information. The example in the book talks about taking a certain area in the tree canopy and then poisoning insects so that all the insects fall out of the canopy. When that happens, about 1,200 different species of beetles were counted. And because they know that usually beetles make up 40% of the diversity in the rainforest, they can extrapolate and say there's probably 3,000 insects in that area. And then if they take into the account the insects and beetles that are on the lower part of the tree or in the soil, they estimate or extrapolate out to 4,500 insects in that tree canopy area. Another way that's mentioned in the book that you can estimate diversity is by forming ecological ratios in well-studied groups. The example in the book talks about the number of fungi species that are usually around compared to the tree species in which they live on. We know the fungal to tree species in certain areas is 6:1, and that tree species are very well studied. So if you know the number of tree species in a certain area, you can extrapolate and say that the number of fungal species in that area is about 6 times as many. Finally, there's something called the species area curve that can help predict numbers of organisms in unsampled areas. Excuse me. Species area curves species area curves extrapolate a curve that has been studied. So for example, here's the well-studied temperate forest where all things have been sampled. This is like where we live, and we've pretty well documented everything that are in these forests. You can see that the curve has a certain pitch to it as you increase with area, and then it comes and flattens out. If you start looking at an area that's not well studied, you can see that the curve has a different pitch, and then you can extrapolate from that. So we can extrapolate that this is the known data from species richness or diversity in the rainforest, and we can take that same curve that we know applies to to area curves and extrapolate here and guesstimate or estimate what the species richness or diversity would be in that rainforest. This allows people to give some idea of what's going on in these environments without having to spend the money or the time to count every species in hard-to-reach places. Scientists agree that we exist in a period in history where there's a lot more diversity than ever before. The sheer number of species is very hard to quantify. Terrestrial ecosystems contain more diversity than oceanic ecosystems, but because the oceans are so big, they contain more abundance. So in this section, we talked about how speciation is promoted through isolation. We also talked about major physical changes that led to the Cambrian explosion and the great diversity of higher life forms on the planet today. Also about the extinction events that ended the Cretaceous period. We also talked about what species richness means and some of the ways we estimated species richness when direct counting is not an option.